Hi, welcome back microprocessor online class. Today we are going to see unit 3. It is Intel 8086. The Intel 8086 to be introduced on 1978, and it was a first 16-bit microprocessor. In 8085 it is a 8-bit processor. It is a first 8-bit processor, but in 8086 it is a first 16-bit microprocessor. The major improvement of 8086 is to improve execution speed compared with 8085 is very high. It is 40-pin dual in package. It is DIP. Similarly, in 8085 has a 40-pin DIP. To next, there are three versions of 8086 which is differ from the frequency level. First, in 8086 it has 5 MHz, that the frequency is 5 MHz, that is a clock frequency. In 8086 2 it is 8 MHz, 8086 1 for 10 MHz. So these are all the versions which is differ from its clock frequency level. Then one more point is it is consist of 29,000 transistors. So compared with the 8085 it is very big. Then another point is it has a 16-line data bus. Before that in 8085 it has 8 data lines and 16 address lines, but in 8086 16 data lines and 20 address buses. So that's why the memory of 8086 is 1 megabyte. Because of it is 20 address lines will be supported, and it has more than 20,000 instructions will be supported because it supports multiplication and divisions, whereas in 8085 it could not support multiplication and division directly. It could not support multiplication and division for 8085 because of it is multiplication will be done on multiple addition, division will be done on multiple subtraction for in 8085. In 8086 it has supports uh, for the instructions separately for multiplication and divisions. Okay, so this is known as pin diagram of 8086, that is Intel 8086. It has 40 pin dual inline package. So there are 40 pins, that is 1 to 20 and then 21 to 40. So 40 pin dual inline package. Now we will see one by one what is the meaning of each pin. First we take pin number 16, that is 2 to 16 comma 39. Here you will see in pin number 2, that is AD14 up to AD0, that is AD0 to AD14. The meaning is 16 to 2, that is AD0 to AD14, that is totally 15 pins. And one more pins in pin number 39, that is AD15. So 0 to 15, which is 16 multiplexed address and data lines. That is, these pins are called multiplexed bidirectional address or data bus. AD means it is address and data. During T1, that is time, just during T1 they carry lower order 16-bit address. Lower order 16-bit address means it takes address. First it takes the address, and then the remaining clock pulse, the remaining clock cycles, they carry 16-bit data. That is AD0 to AD7 for the lower order byte of data, and also AD8 to AD15 for higher order byte of data. So there are two uh, sections of higher order and lower order byte data to be carry the same multiplexed and multiplexed address and data buses. First it transfer, first it carry the address of the data address, as well as the same bus it carry data also. That's why the pin number 16 to 2, then 39, which is called as multiplexed address and data lines. Go to next. Then pin number 35 to 38, that is unidirectional. Before in bidirectional for AD0 to AD15, this is unidirectional, the one-way communication. These lines are multiplexed unidirectional address and status bus. There are two meaning is there, address and status bus. During T1 they carry higher order 4-bit address. During T1 the 4 bus it carry 4-bit address, that means A16, A17, A18, A19. These are all the 4 addresses. First T1 carry the first higher order 4-bit address. After that the remaining clock cycles they carry status signals for S3, S4, S5, S6. So this is for multiplexed unidirectional. Before in multiplexed bidirectional means it is AD0 to AD15 for address and data lines. Here in multiplexed unidirectional means first it's carry higher order address for A16, A17, A18, A18, A19. Similarly for the same remaining clock cycles they carry status signals for A3, A4, S3, S4, S5, S6. Okay, this is the meaning of unidirectional address and status signals. Go to next. Pin number 34 or S7. BH means bus I enable. The bus I enable, which is indicating to transfer data over higher order data bus. That is to be BH equal to 1 means it transfer data over higher order data bus, that is D8 to D15. Okay, it is to be enabled to transfer the data. Or in the 8-bit input output devices use this signal. It is also multiplexed with the status pin S7. Okay, multiplexed with the status pin. The pin number is S7. Okay, so BH, the main purpose of BH is to indicate it is for 1, so the data to be transferred D8 to D15, that is higher order data bus. I'll go to next. So this is for control signal, which is read signal used for read operation. So read signal is mainly used for read operation. It is also an output signal, and it is an active low signal, that is RD equal to 0. From the low signal, that is RD equal to 0, it read the operation. Okay, then ready. This is an acknowledgement signal from slower IO device or memory. Ready, which is goes to I. It is active I means it indicates the device is ready to transfer data, or it is low means it could not ready to transfer the data. Okay, because the microprocessor is in dead state, that is low. I means it indicates to the device is ready to transfer the data. That is the two meaning. I means it is transfer the data ready. The low means Yeah, the microprocessor still in wait state. Next, reset. So it is also an active high signal, the system to be reset. When the signal is high, the microprocessor enters into reset state, and also that terminates the current activity. The microprocessor, it can be reset by using at least 4 clock cycles for to reset the microprocessor. Okay, so this is the pin number 21. Then pin number 18, INTR, it is interrupt request pin, which is active high signal. It is also a level triggered interrupts. Okay, before in 8085 can detailedly explain what are the interrupts and what are the types of interrupts and what is the importance for interrupt pins. Now with this in 8086 only one pin is there, it is INTR. It's the interrupt request pin which is active I. Next, NMI, non-maskable interrupt signal. It is also active I signal. Before in INTR is a level triggered interrupts. This is edge triggered interrupts. Okay, so these two pins are called interrupt pins. Next, pin number 23, it is test. So from the test, the pin number 23 is used to test the status of coprocessor 8087, because the microprocessor 8086 will be connected to the other peripherals like coprocessor 8087. Suppose if the connected pin is BC, that is pin number 8, the BC pin is connected to 8087. If the BC pin is low, the execution continues else the microprocessor is in wait state. Okay, that is 8086 microprocessor is wait state. Then it worked 8087, that is a coprocessor will be worked. That is the meaning of test pin, used to test the uh, coprocessors. Next, clock. Basically the clock input provides time for processor operation. How the processor or uh, the time to take the processor to complete a operation, that is to be calculated by using clock signals. That is the range of frequency is different from different versions, like 8086 is at 5 megahertz, then 8086 2 for 8 megahertz, 8086 1 for 10 megahertz. These are all the frequency level which is differ from one version to another versions. Okay, then last one, VCC and the VSS. These are all the power supplies. VCC for power supply signal, which is connected pin number 40, and VSS is a ground signal which is connected pin number 20. In 8086 which support only 5 volt DC supply through these two pins. In 8085 also 5 volt, which is connected the two pins.